he's a freelance consultant, and he's worked with organizations of all scales. Very keen focus on software architecture, having in mind security, performance, maintainability. Very active open sourcer, and likes to play with experimental libraries and contribute to Zend framework. Chris, it's my pleasure.
Thank you very much. Okay, so there's quite a lot to get through, so I'm going to set off straight away. This talk is called Event-Driven Development. It's kind of a play on the time you always get all these time like test-driven development. So it's sort of, I'm just using it as like a term to discuss a number of different techniques around doing event-driven design and event-driven architectures and event-driven techniques. And you've probably come across a few of these before. I mean, there was a talk earlier on in the conference on one of them. But what we're going to look at today is how you can actually fit these various pieces together and build a full system. I'm presenting these techniques as kind of like a whole piece to try and fill in gaps that you might have if you've been to a talk on any one specific thing. You're like, well, how does that relate to everything else? But it doesn't mean that you have to do all of them in order to be doing it right. You can pick and choose bits and pieces from this talk and implement the bits that you think will help you. A few of the topics I'm going to be sort of touching upon today, I mean, I'd usually ask people to put their hands up, but you're quite a long way, so we'll skip that bit. But event sourcing, as I said, there was a talk earlier on in the conference on that, so maybe a few of you went to that. The idea is, instead of representing state as a bunch of database tables where you store the current application state in some relational model, you represent your state as a series of events, a series of changes, and then you sort of keep history as well as just the current state. Works, if you want like something you've probably come across, Git, it's very similar to how that works. You've got lots of deltas of your code changes. Another thing we're going to look at is event-driven or message-based architecture. So this is a pattern where you've got multiple microservices in a system. You can use an event or message-based architecture to exchange state between them. So instead of one microservice making a GET request to something with an API and saying, give me all the users, because I want to do something with users, the users microservice would publish events every time a user registered, and any services that were interested in users being registered would listen to those events and store a copy locally. A lot of the techniques that you use in event-driven architecture are actually very similar to the ones you use for event sourcing. They're just at a sort of a higher level. Okay. Another thing we're going to look at is maybe not quite, it's not event in the title, so you might think, why is this in the talk? It's task-based user interfaces. It actually fits into event-driven patterns quite well because instead of presenting a user with like a huge CRUD form to edit a piece of data in your database, you focus your UI around the particular thing that the user is trying to do. So that actually allows you to derive events from what the user is doing a lot better, and then feed that into your system, and it improves the design of the overall system. An example is that you wouldn't just have a huge form with your order and somewhere down in the middle of the screen there'd be a drop-down, order status, shipped. You'd actually have a specific dedicated page in your UI where you'd go, right, click a button, ship order, and it'd bring up a little box with all the fields you need to fill in for shipping an order, and then you'd submit that. And you wouldn't have any of the extra, you wouldn't be able to like change the customer's name or anything like that, unless it was relevant to shipping it. Last one I'm going to mention, not actually going to do this, talk about this much in the talk, is event storming. It's a software design technique which focuses around the actual events that occur in your system. Now, obviously, if you're making use of the other three techniques, event sourcing, event-driven architecture, task-based UI, it's a really good sort of like little workshop to run with some developers and business owners that know what the system needs to do. You can run this workshop and you can use it to help design your software. I'm not really going to talk about it too much more because it's really something you need to do. So I mean, there's quite a few conferences that actually do event storming workshops. I'm giving one in PHP Benelux next year. So if you're actually interested in actually getting your hands on and doing this, look out for one of those. So before we go any further, what is an event? So all of those techniques from the previous slide have origins within domain-driven design. For those of you that are maybe not familiar with domain-driven design, the idea is that you let the business domain, so if you're doing car rentals, your business domain is car rentals, so you let the language that people who know, the people who run the company and know lots about renting cars, you use the same language that they use to discuss renting cars in your code base. And by bringing that language in, you make the code itself more accessible to those business experts. And that means when you're in a design meeting and say, well, okay, well, how do we deal with cars that have been not returned on time? You're going to be using the same language that they are to describe that, and it'll help understanding and help you actually solve the problem much easier. Events don't magically appear in your system. Generally, they're only raised in reaction to something else. This could be, something your user actually pressing a button that could cause an event to be raised. It could be something happening in an external system, a webhook call from your payment provider, or it could be the passage of time. Okay, so if a car is due to be returned on the 3rd of May, you might raise an event on the 4th of May saying, well, that car's not been returned. So to sort of set out some sort of rules on what an event is, it's something which has happened. Okay, it's a fact about the history of your system. When you are talking about events, you should do so using the past tense. So it's something like order cancelled. And when you're actually discussing it with the wider business, it will help their understanding if you try and use full sentences. So an order was cancelled. That is probably an important event in many systems. An event should be something that's relevant to a subject matter expert. So if you go and talk to someone who really understands the business but has no idea about databases and transactions and that kind of thing, if you were to show them a list of all the events that happened in a customer's account, they would know what was going on. They would understand what state that customer was in. In order to ensure that understanding is possible, we need to avoid using technical terms in events. So we're not talking about on-click events or transaction-committed events. They should be relevant to the business. They shouldn't be using technical language. You might have those events in your system, but they're not the ones that we're focusing on today. Okay? And finally, as I said before, they are raised in response to some sort of input. That could be from a user, an external system, passage of time. Sometimes you also get events that are raised in response to other events. But you should be able to sort of trace these back, and you'll have like a bit of a sort of a history that says, well, this event was raised, which caused this event to be raised, and you go on. But you'll be able to trace this back to some sort of original input. So that leads me nicely on to considering the first use case, a user actually inputting something into your system. And we're going to talk briefly about task-driven UIs. So computer systems traditionally have been modeled around the data they contain. A lot of times you'd start off a project and someone would say, well, here's all the data that we want to store in our system. And you'd go away and you produce a database diagram with entity relations, that kind of thing. And the problem with that thinking, I mean, it's a reasonable way of designing a system, but what it tends to lead to is UIs that represent the database structure. A task-based UI is trying to break away from this data-oriented design and move into a task-oriented design. So consider this UI. I mean, you may well have something like this in your own application, a big long form that allows you to edit everything in a database. A user probably accessed it, clicking an edit link in a list of orders, or perhaps a search result. And then when a customer calls in and says, oh, I'm really sorry, I accidentally bought the same thing twice, I want to cancel one of my orders. So your customer service staff will load this page up and try and set this order status to cancelled. From the UI, it's not actually obvious that they would also need to fill in that cancellation date and the cancellation reason. And if they forget to enter those things, you've probably got some validation on your back end that says, hold on a minute, you can't set the state to cancelled unless you input a reason and a date. Only the user's experience of having cancelled an order before will potentially stop them from making this mistake and wasting time with a validation error. On the contrary, if you follow a sort of task-driven UI, we have a much simpler interface. Again, the user's probably arrived at this via a link from a list of results. So they've done a search for the order ID or the customer name, and instead of just having a big edit button, you'll have a cancel order button, you'll have a log payment button, you'll have everything you can do to an order, and you might show and hide those based on the current state of that order as well. So obviously if you've got a cancelled order, you don't show the order shipped button. Now here we've only got the fields that are required, which, given that we are cancelling an order, we know implicitly that we need to set the order status to cancelled, so we don't need to show that in the UI. And again, the date, well, it's happening today. So the only field that we actually need the user to fill out is the reason. So they type in customer duplicate order, click the cancel button, and our back end takes care of all the other bits and pieces that they would have needed to fill out. Even without training or experience, your customer service staff are going to find that much easier to work with than the interface on the previous slide. So, why is this relevant? Everything a company does is part of some sort of process. Is it fulfilling an order, or is it renting a car to them, that kind of thing? There's a process behind it, a set of steps that need to go through. By giving your users a basic CRUD-like UI, you're relying on their knowledge of the process. Your core business logic exists only in the heads of your users. Now, has anyone ever tried unit testing a user? No? I assure you, they're not very happy if you try. The task-based user interface isn't revolutionary or new. You possibly already have some things that look like that. But they really help the users actually get to use your software. And a really good idea, just even if you're not doing anything else for the rest of this talk, task-based UIs are a great user interface improvement for your users. So the question now is, why have I included task-based UIs in this talk? What relevance do they have? I've brought these into the beginning of the talk because one of the biggest disconnects I've had when I've been talking about these techniques before, people have been asking questions, is how do you get events? When all you've got is that big CRUD form editing, how do you get relevant events from it? Obviously, if you've got that huge form and someone's changed the order status to cancelled, and you've got to do a lot of work behind the scenes to try and work out what the event should be. And quite a lot of people just end up with an order edited event, which isn't, I mean, it's better than nothing, but it's not a very focused, it's not a very specific event. If you take the second UI, however, it's very obvious that what you're going to get out of that is an order cancelled event. So having the task-based UI makes it much easier to understand the intent of the user, what they were intending to do, and that in turn allows us to generate a more relevant business event from their actions. So, next thing we're going to look at is event sourcing. It's probably one of the core parts of these event-driven techniques. It's a low-level design pattern. But many of the concepts also apply when you're using event-driven architecture at a high level. Now, at the basic level, it's the concept of representing state as a series of events, a series of changes. This diagram shows probably what a lot of you have got in your systems right now, a relational database model. Well, I've done something, it's a basic shopping system here. You've got customers, you've got an order, and each order has got a line item, so they can add multiple items to their cart. Whenever a customer goes on the website and says, well, I'm going to insert I'm going to buy a new item, I'm going to add it to my cart, we add a row to the line item table, and then if they remove it, we delete that row again. If they decide they want 3 instead of 2, we update it. We've only got the current state though. Correlate that, contrast that with this diagram. This is a set of events that could have been raised while the customer was going through the shopping system. You've got an order created event when they first enter the site and log in. You've got a line item added when they add the first item to the basket. Maybe they add another one, they delete one, update the quantity. We store each of these events separately. So that means that if we want to load a user's basket back out, we have to load an empty order object in our code and then replay each one of these events to get up to the current state. But once you've done that, you will arrive with a model in memory that looks exactly the same as if you just loaded the order out of your database from the relational table model. But what does that actually look like? That's a very abstract, you can say, okay, I accept that you can do this as a series of events. How do I actually go about implementing something like this? What does the architecture look like? And obviously, the events themselves, you can say, well, okay, I've got all these different events, but I want to actually, how do I save them? How do I load them? What do I do if I want to read things out? How do I make it quick? And a lot of the terminology is rooted in domain-driven design, and maybe it can be quite a daunting experience, because that's roughly what my architecture diagram for an event source system looks like. It's quite a lot of stuff to kind of invent yourself if you've just seen that event diagram. Now, don't worry about trying to take this in right now. We're going to break it down and go through it in little bits. But that's the full thing. It's based on a sort of like a clean /onion /hexagonal architecture pattern, where you've got your domain model, your core business logic sits in the middle, and that only knows about other bits of core business logic and domain. Around that, you've got sort of orchestration. Domain orchestration is what I describe it as, which deals with all the routing of events and commands and things into the system. And then on the outside, that's where your framework sits, your databases, your concrete implementations of things. Okay, so you can swap them out really easily without having to change your internal domain model. Going to start where we left off with the task-driven UI. You've got that nice order cancelled UI. Users click the submit button. What actually happens? So the first thing that it hits is a controller. If you do an MVC, obviously if you watch the previous talk, you might have a slightly different approach, but it's not massively important here. It's an implementation detail. And what I do is I have a validation class which will validate that the user has entered a cancellation reason. And it's more than 10 characters, but not more than, say, 250. Okay, so we've got that validation rule. We make sure that's been entered by the user. At that point, we augment that with things like the current date time and any other information that we might be able to pull from the local environment. And we construct a command object. A command object is a very basic PHP class which just has fields for everything that is relevant to that command. So it'll have the cancellation reason, it'll have the order ID, it'll have the order date, the cancellation date, which is now. And then we wrap that up and we push it onto a command bus. From there is some routing logic contained within that command bus, which will find a handler for that command. The command handler then is responsible for talking to a repository, which will load from an event store all the events which have happened previously on the order, and then it will construct a brand new blank order object and return it to the command handler after having applied all those events. So we've got the current state of the order. The command handler will then call a method. It could be cancel order. You could actually have a specific method that it knows to call. More recently, in the systems I've been building, I just have a handle method on the domain model, and the command handler just passes the command as a whole through to that, and that allows the domain model itself to deal with handling it and extracting the data that it needs from the command. After all that's done, we grab any new events that the domain model might have raised, order cancelled, for example, or maybe unable to cancel order, already shipped event, if you've got an error. Could also throw an exception. It depends how you want to model it. And then we save any of those new events back into the repository. Looking inside that domain model, it's the heart of the application. It's where your core business rules sit. Things like you can't cancel an order after it's been shipped. That rule will be enforced inside the order model. I tend to organize my models as a single or group of entities which act as a whole, and I define a root entity. So if you're thinking about that e-commerce model that we had before, we had a customer, that would be one sort of group of entities, and we have an order, that would be an entity, and those line items would be an entity, but if we ever wanted to interact with any line items, we wouldn't do so directly, we would only do so through the order object. That allows the order object to say, okay, well if there's any rules that say an order can't be shipped if it has no line items, it's able to maintain that rule. You might have a rule that says we can't put more than 10 items into an order because our legacy finance system crashes if you have more than 10 line items on an order. So you put that rule in there, and it can maintain that consistency and say, oh, you've tried to add an 11th, that's going to break our finance system, you can't do that, we'll have to apply some sort of workaround. Okay, so all of your business rules sit in there, and the root entity is responsible for maintaining that consistency. If you sort of think about it in more database terms, that boundary represents a sort of a transaction boundary. Okay, so if you want to maintain something in a consistent state, you do it inside a transaction. Those boundaries are transaction boundaries. How that works is another sequence diagram. When it actually calls the root of the model, as I was saying before, the repository will pass all the events to a blank copy of that domain model. That domain model will then loop through all the events and apply them. So usually what would happen in your model is you would split your handling of a new command that's coming in and the application of an event. So you have one method that you say you cancel order method, and that would validate that you can cancel the current order. If it can, it would raise an event. Once you've raised an event, though, when you have a separate handling method for that event that will update the status to cancelled. When you read it back out of the database, you won't repeat that validation because an event is a fact. It's something that has happened. The order has been cancelled. Even if something's changed in the meanwhile, that's something that you've got to cope with. You can't throw an exception because the order can't be cancelled anymore because it already has been. Okay, so that means that when you actually reload it from the database, all those applications of the events have to be safe to do. And then you apply the new order cancelled event, it updates the internal status. The command handler and the repository will grab the new events and save them. After it's done that, any new events, once they've been committed into your database, it will publish them to an event bus. And that's where the real value actually comes from an event source system. Once they're published to a bus, you can have lots of things working on them. So I've put a couple of examples here. There's processes. They're probably the biggest piece. They will do things like, okay, so an invoice has been created. That means we actually need to to do some of the process, but we might get some performance problems. It's okay if you're looking at a single entity, but if you need to query over multiple entities, or if you need to rapidly display UIs, you don't want to be loading up all of those potentially hundreds of events every single time. So we create a projection. The idea is it turns a stream of events into a read model of some form. Could be a relational database table, could be a document store like MongoDB or Elasticsearch, whatever suits your use case. They can be eventually consistent. This means that you might decide that it takes a very long time to update your data warehouse, so you're going to batch up a day's worth of events and ship them off overnight at 2 a.m. so you don't tie up that data warehousing system when your marketing department is trying to use it to do some analytics. They can be rebuilt. An important feature of projection is because you've got all those events stored, you can throw away the entire content of that projection, and then you can replay all those events through your projection code and rebuild it exactly how it was. Or, if you've discovered a bug that's not quite creating the projection in the way you need, you can throw it away, fix the bug, and rebuild it from the events and get it in the right state. Obviously, to support rebuilds, you need some sort of mechanism to pull all those events out of your event store. Likewise, if you're dealing with events coming from a remote service, which we'll get onto in a bit, that remote service is going to need to expose an API so that you can say, well, give me every event that you've ever published about orders. And then you can grab all the events, rebuild your projections, and then continue reading off your message queue for live events once you've rebuilt them. Bring that into a more visual thing. You've got a stream of events, passes through some projection code, and then you can build a relational database table for doing reporting on, perhaps. You could put it in a NoSQL, like MongoDB, for really rapid UIs. One technique I've seen used at a couple of companies is they'd put everything that was rated to a particular page in a NoSQL MongoDB database, and that meant that all they had to do to display that page, despite the fact that it would have been a really heavy query if they'd done it on their relational database model, was load a single MongoDB document by ID, put it into a PHP template, and return it to the client. Every page loaded in under 50 milliseconds. So it's quite useful to sometimes have the two different models for two different use cases. The third, one of the other types of event lists is process managers. As with projections, you can use these for both locally raised events and events coming from external services. Their role is to track the state of a business process over time, so the process of actually getting paid when you've raised an invoice. They can also feed back into your system by raising new events and firing off commands. So unlike the more simplistic event listeners, which maybe listen to an order completed event and send an email, thanks for your order, process managers are there to manage both, yes, an order's been completed, we've taken the payment correctly, the happy path, but also handle situations where that maybe goes wrong, and we need to take some corrective action, like getting the support staff to ring up and say, hey, we need a new payment method because your card was declined. Can you use a different card, please? They are there to handle business logic that arises from events. You can sort of think of maybe in a loyalty scheme where you've got, say, a user places 3 orders. So you've got 3 order completed events that happen somewhere in your system. A process manager keeps track and says, well, we've got 1 order completed, great. 2 orders completed, perfect. 3rd order, amazing. Let's ship them a discount code. Okay, and a process manager keeps track of that over time, does it, and then resets, and when they've made 3 more orders, the discount code. The best way of thinking of a process manager, usually, is as a state machine. So you get an event from your system into a process manager. That causes the process to transition into a new state. And at that point, we may be raising new events or sending commands. I also have my processes capture the events that they've responded to in their own history, so they themselves are event sourced. Keep track of failures. Generally, when a process fires something off and says, okay, we've raised an invoice, we need to now contact our payment provider and take some payments, you don't know if that's successful immediately or not, potentially. You might have a webhook that comes back 5-10 seconds later. So it's important that you sort of keep track of what you've fired off. A technique I use for this is I will tend to raise two things. One that says, go off to Stripe and take a payment from this card. The other that says, you know what, wake me up in 15 minutes, if please. And then if Stripe responds and says, yes, payment completed, and I get that response back, everything's fine. If, after 15 minutes, nothing happens, I don't know if maybe that API call to Stripe failed, or if Stripe's down, or there could be a lot of things that went wrong, but I get that event back that says, well, 15 minutes has passed since you tried to take this payment, you need to go and take a corrective action, and maybe send it again, or alert a customer support agent to look into what's gone wrong. Be very careful with replays. Projections should always be safe to throw away and replay. Process managers, maybe not. Obviously, as they're raising new events and new commands, anytime you replay one, it's going to raise those events. If you've got event listeners sat on the end of those, you're potentially going to charge a customer twice, send lots of emails you didn't mean to. So it's probably best to think of them as you can't replay them. But if you do, you need to really carefully consider, well, what's actually going to happen if I do this? So take a look at the loyalty scheme that I mentioned. This diagram represents that process. You have a start state, a purchase is made, events received, and what this loyalty scheme rules are is if you make 3 purchases within a year, you get a discount voucher. So the first thing it does is raise an event that says, let me know when a year's gone past. So there's some sort of scheduling component that will do that. It then just transitions into the state of 1 purchase has been made, I've got nothing else to do. It receives another purchase made event, and it transitions into the second state, 2 purchases made. If at any point that event comes back and says, well, a year's passed, it resets, goes back to the beginning. You've got to start over and make 3 more purchases. So we go back to the start. If we receive a third purchase made event before that year passed event comes back to us, we issue a discount voucher and loop bound, return back to the start. That's a basic process. Going to move on now. We've covered a lot of the important patterns in event-driven systems. But so far, these application patterns have been for sort of a single system. You're looking at a single service in your system. And it's at a much lower level of architecture. Event-driven architecture, on the other hand, is at a much higher level. So it's inter-service. These techniques are best suited to sort of a microservice style thing. You probably don't be doing it with too much with third-party services, but you can sort of abstract it a little bit. But the idea is you're exchanging events between services to exchange state. So you might have a set of microservices that look like this. You've got a ticket service, a user service, loyalty scheme service. Every time something interesting happens, those services can raise an event that is published to all the other services. So whenever a purchase is made, the ticketing system raises yep, we've received a purchase, and it raises an event. The fraud service can then pick it up and say, well, let's just analyze this thing and see if it's okay or not. If not, it can flag something, and a customer service agent can pick it up, and maybe it raises an event and says, okay, it's all right, you can continue with the process. It should be noted that when you're doing it at a high level, you don't publish every single event that your low-level models produce. The various services probably aren't interested in the intricate details of how an order is produced. They only really care that an order has been placed. So you would probably wrap up all of those events inside your service and publish a single event at the end. This helps to reduce coupling between services. So if you want to change the order process, and the only event that you're publishing to external systems is that order placed event, if you decide that you need to tweak the order of events inside that order service, you don't then have to go and edit all your other services that rely on orders being placed, because they're only relying on that final rolled up event. You're not also limited to, this is another sort of misconception that some people get, is you're not limited to just using that event bus to communicate. You can actually use APIs as well. Some of the things I actually build when you've got sort of cross-system processes, and this doesn't necessarily have to be separated by a network. These could be just modules within inside a single monolith. You have an event-driven system on one side, which raises some events. A process manager gets hold of that and says, well, we need to contact a different module, a different system. And so it raises a command, which falls onto the command bus. And you have a command handler that sits in your infrastructure layer, which knows how to communicate with an external system, say your payment provider or another microservice in your architecture. And it will make an API call across, a REST API call, and says, okay, I need you to take a payment from this user. You'll have the same event-driven system within there. The command gets dispatched. We go through the process that we saw many slides back now. Once those events are rolled up, you publish it to an event bus. An event listener, again, sitting in your infrastructure layer, knows how to publish that to RabbitMQ or SQS or whatever message queue you like using. That event listener publishes it to the queue. And this service that originally originated the request has a listener that listens to the queue, passes it through an anti-corruption layer. And what that's there for is you've got an event coming from your payment system, and you want to translate it to an event in your system. Initially, this might be a one-to-one mapping. You map all the fields over and everything like that. But say the payment service changed. They changed the event structure. They were going to add some additional fields or delete some fields or combine some fields. You don't want to have to change your business logic because someone else changed their system. Well, that's what the anti-corruption layer is there for. It will take the new event and tweak it so it still matches the format that the rest of your application expects. So if there's changes in external systems, you've just got to make a change in a single part of your application and everything still works. Obviously later on you might say, well actually we could quite use some of these new fields, so you can evolve your event model to use those new fields and change your anti-corruption layer to pass them through. But that means you're not coupled to making the change at the same time as your external system. You can do it when it makes sense. So to go on to conclusions, what we've sort of gone through today, we've looked at various processes for handling events in systems. A few things I'd probably note is, as I said at the beginning, you don't have to use all of them. And another thing is, you don't have to event source everything. Okay? A lot of people sort of think, well, we're doing event sourcing, so we're going to event source the whole application. You probably don't need to. You want to event source the core parts of your business, taking an order, taking a payment, handling customers. If you've got an admin panel that's got some settings in it, probably don't want to event source that. It's not core to your business. Setting your API keys for your payment provider, that shouldn't be event sourced. That should just be a database table. Okay, so you can use the event sourcing part and the event-driven architecture part in the core parts of your system, the bits where it's important, the bits where it will give you an advantage. But you can use regular tables for things where it doesn't really matter. Okay. So I hope this has sort of filled in a few gaps, and you can sort of think of how you might use bits and pieces of this or all of it. I do actually have an open source project which might need a bit of explaining, but it's a conference application that deals with ticket sales, and I'm working on something to handle speakers and deal with things like booking their travel and stuff. That's on, if you search GitHub for conference tools, there's a big organization with a bunch of things. There's actually some code examples. The architecture is pretty much the same as what I've been going through here. There's a few tweaks and slight differences, but I hope everyone's sort of enjoyed this talk. If you want to follow me on Twitter, I'm at GitHub my GitHub there, which you'll find a link to the conference tools from if you're interested in looking at the code, and my blog where I've actually explained a few of these few event-driven concepts and a few other things that you might find interesting. I also, I mean, if you didn't kind of notice, I run a conference, PHP Yorkshire. That's in York. We're next one's in April on the 3rd and 4th. We've currently got a call for papers open, so if you feel like you could get up on stage and speak, we'd be happy to have you. And we've also got a few of these elephants. If you need one for your collection, come see me later. They're on sale. So thank you very much.